Hello students, in this video we are going to discuss JEE Mains 2009 question which is from the topic of electromagnetic induction for RL circuits. Let us read the question. An inductor of inductance L is equal to 400 millihenry and resistors of resistance R1 is equal to 2 ohm and R2 is equal to 2 ohm are connected to a battery of EMF 12 volt as shown in the figure. So in the figure, this battery EMF E is equal to 12 volts. These two resistances R1 R2 are both 2 ohms and this inductor is having inductance 400 millihenry and initially the switch is on. Further, the internal resistance of the battery is negligible. The switch S is closed at t is equal to 0. So we will close this switch at t is equal to 0. As soon as we close this switch, the circuit will be complete and the battery will begin to deliver current. The current will flow along this path. Some current will go into the resistance R1 and remaining current will go into the LR circuit branch, inductor and resistance R2. We have to find out what is the potential drop across the inductor as a function of time. That means what is the potential difference across the inductor. So let us see how can we solve this question. See, this question belongs to the topic of LR circuits and I have made already a video whose thumbnail is shown here, where you can go and study the full theory of the LR circuit, where I have done the derivation of the formula for the growth of current with time and its expression of current I with respect to time t. So I will present here the method of solving this question. Firstly, the main problem here is that there are two branches, there are two parallel branches. One branch contains resistance alone and other branch contains inductor and resistance both. How can we simplify this circuit? Let's see. Obviously, we are not going to find equivalent resistance of R1 R2. That would be wrong in this question. Firstly, we observe that when this switch will be closed, then all these three branches are in parallel. We know that in any electrical circuit, the branches are in parallel, then the potential difference across all the branches must be equal. Therefore, if this battery is developing a potential difference of E in this first branch, same must be the potential difference across this resistance R1 and same potential difference across this series combination of inductor and resistance R2. So we have indicated here that EMF or the potential difference across the series combination is E and the potential difference across R1 is also equal to E, which is same as that of the battery. Now, can we say that only this much part of the circuit, if we take only the L and R2, the potential difference between them is E, okay, like this. So just let us consider only this part of the circuit where inductor and resistance connected in series and potential difference is E. So can we imagine that this potential difference between these two ends is created by a battery of EMF E. So we can assume that this inductor and resistance which are connected in series, they are actually connected to a battery of EMF E because the potential difference across them is equal to E. So therefore, this circuit gets simplified to this simple circuit. So now we can proceed further because we have already learned our derivation in the previous video that what will be the current flowing in this kind of circuit where only inductor and resistance are connected in series with a battery. Let's proceed. So start writing solution like this. Firstly, we will write down what are the things given the question. Data given the question. Inductance is 400 millihenry. Milli means 10 to the power minus 3. So therefore 400 into 10 power minus 3 Henry, which will become 0.4 Henries. 10 power minus 3 means we have to shift 3 places of decimal till here. Then the resistance R1 is given as 2 ohm. Resistance R2 is also given as 2 ohm. And the EMF of the cell is equal to 12 volts. Now method number 1. So in this video I am going to present two methods of solving the question. In the first method, what we'll do that current in the LR branch at any time t would be equal to is given by this formula. Current I in this circuit would be equal to, after closing the switch, the current in this circuit would be I is equal to E upon R 1 minus e power minus RT by L. This formula has been derived. This formula I have already derived in one of the previous video, whose description I will give below the video. Now, so you can find out the link in the description below and you can look at the full derivation of this formula. Okay, also note down here that in this formula, this R, which is resistance, we are going to take the resistance R2 here, because the R2 is the one which is connected in series with the inductor, not R1. R1 is not needed here. Let us proceed further. Question has asked what is the potential drop across the inductance. Potential difference across an inductor, standard formula is that it is L into di by dt. L is the inductance and di by dt is the rate of change of current with respect to time. As you can see here in this above equation that the current I is given as a function of time t, so therefore we can do the differentiation of di by dt. So therefore VL, potential difference across the inductor, can be written as L multiplied by d by dt of current I. So I we put here, the whole expression of I we put in front of d by dt. So now we have to differentiate this expression to find out the potential difference across the inductor. So this is the expression that we written on the previous page. Let's continue. So we have to do the differentiation of this much part. So here E upon R is a constant value. Constant can be taken out of integration. So next step we write down L into E by R. And the remaining thing is d by dt of this 1 minus e power minus RT by L. Then next step, this constant L E by R remains outside and we differentiate this bracket. So we write down differentiation of 1 and minus differentiation of exponential function. Then what happens in next step is that differentiation of 1 would be 0 because 1 is a constant value. Differentiation of 1 is constant. Differentiation of 1 is 0 because 1 is constant, and differentiation of exponential function is the same as the exponential function. So therefore differentiation of e power minus RT by L would be e power minus RT by L, and then multiplied by the differentiation of this power of the exponential function. This is called as a chain rule of differentiation. We not only have to write down this exponential function. See, we say that differentiation of exponential function is exponential function, fine, like d by dx of e power x is e power x, but the power also has to be differentiated. So d by dt of minus RT by L we multiply here. So in the next step what we can do, L E by R is outside, 0 is here, so 0 is gone. Now this is we keep same thing, and now d by dt of minus RT by L, how to do? Minus R upon L is a constant, you take it out of differentiation, and d by dt of t, that means dt by dt, which will become 1 in the next step. So now let us simplify this. Here minus into minus will become plus, and R upon L can be brought outside. So L E by R into this R by L, and e power minus RT by L remains here into 1, dt by dt is 1. Here L cancel, R cancel. So finally we'll get only E and multiplied with this. So EMF multiplied by e power minus RT by L. This is the potential difference across the inductor after time t. And we can now substitute the values which are given in the question. The EMF was given as 12 and resistance, as you know, we have to put as R2 T1L. So what are the values? We'll put him here. So EMF was 12 and e power minus resistance is 2 ohm. So put R2 is equal to 2. And inductance was 0.4 Henry, so we write down here 0.4. Then 2 upon 0.4 will be 5. It can be explained like this: 2 divided by 0.4 is equal to, so multiply the numerator denominator by 10 each, so 20 upon 4. 2 into 10 20, 0.4 into 10 4. This becomes 5. So we get this. This is the answer of the question. The third choice of the objective options given. This is the answer of the question. This was the first method of solution, and now I present you the second method, which is smaller than this previous method, and also it will not require any kind of differentiation calculus. Let us look at the second method. Once again, let us observe this circuit. When the switch will be closed, current will begin to flow in the circuit. Now, in any kind of series combination, whether it is series combination of two resistances or series combination of two capacitors or series combination of inductor with capacitor, the potential difference across inductor plus potential difference across resistor, this two summation must be equal to the potential difference of the battery. That means VL plus VR should be equal to E. If suppose we had two resistances, then potential difference of first resistance plus potential difference of second resistance must be equal to the EMF of the battery. This equation is true for any kind of series combination. So whichever things are connected in series, the sum of the potential difference of all those series elements must be equal to the potential difference of the battery connected in the parallel branch to it. Very well. So VL plus VR is equal to EMF E. Now we know that potential difference across the resistance is always I into R according to Ohm's law. And we already know the expression for I. We'll substitute here. Before that, we can rearrange the terms. We can say VL is equal to E minus IR, sending IR to the other side, E minus IR. Okay, so let us continue here. VL is equal to E minus IR, and as we know that the current as a function of time t in any LR circuit is E upon R into 1 minus E power minus RT by L. We substitute in place of I, and into this R is written here. Now this R cancel, and we'll get E minus E into 1 minus E power minus RT by L. Now let us open this bracket. E minus E into 1 is E, and minus E into minus of this will become plus sign EMF into E power minus RT by L. E cancels, and we get this expression. See, this is the same expression that we obtained on previous page also, and we now substitute the values and we'll get answer as 12 E power minus 5t. So in this manner we see that the method number 2 is quite easier, because it does not involve any kind of differentiation. We can get the answer in very quick number of steps. So it is recommended that the second method is well suited for the JEE Mains exam, and I hope that you understood the procedure of solving the problems and you will remember both the methods. Thank you for watching my video. Please give your comments below that what do you feel about this video and the two methods of solving the problem. Please like it and share it. My name is Physics Guru, and my YouTube channel is youtube.com/thephysicsguru.